And now we'll have our keynote address from Jim Reuter, NASA Space Technology Directorate Associate Administrator. Thank you.
Good morning. Good morning. I'm really enjoying being here. It's you know, I've been hearing for a while lately how much is going on at UTEP and the changes that are happening. And I was like, I don't think they have huge endowments. How are they doing this stuff? So I really wanted to see. And so then the opportunity that came that the Lunar Surface Innovation Consortium chose you among a lot of applicants to host this event this year was a great opportunity for me. In fact, I had to change my schedule a little bit just to be able to get here for it. And so I really appreciate it. And it's wonderful. I get to see the Aerospace Center this afternoon and stuff. And so I'm looking forward to that tour and just really excited about it. You know, I know I had a chance to talk with Congresswoman Escobar just before we came up here, and she talked, and certainly it is a busy time for her, but she was a great advocate, and we really appreciate her office and how much she's supporting, you know, particularly with JSC being right here in Texas with her. And so we really appreciate the continued support for NASA. We strive to we take pride in ourselves of creating new companies, growing companies, creating opportunities for and inspiring our next generation. So I'll have the next chart, please. So I have a few minutes time that I wanted to talk about a little bit about our portfolio for space technology. And it was promised yesterday that I'm going to do some of my talking about the envisioned futures and what are we doing with objectives and stuff. So I'll spend a bit extra time with that as we go through it and try to watch my time because I get excited. So I tend to talk a little longer. But anyways, our portfolio for space technology crosses the range of technology readiness levels. So we work all the way from, you know, on this chart left to right, the early stage innovations, the things that are concepts and ideas that you get to test out. To the SBI, we run the SBIR program for the agency. We run tech transfer for the agency. And then we have technology maturation, which is our technology readiness level scale type things, the things that are in the laboratory, things that you want to bring up from concepts, things that you want to take on to the next step and implement and flight demonstrate and implement. And so it's kind of the cornerstone for us. And I'm not going to read all our programs, but we have 12 programs here, and we have a huge activity in this area that is the reason we're all here. It's the Lunar Surface Innovation Initiative that's there, including the consortium. And I'll talk a little bit more about that in an upcoming slide. So anyways, through that, we truly believe technology drives exploration and it drives the space economy. And those are fundamental aspects for us as we're going forward. Next chart, please. So I want to talk a little bit about what's, you know, we're here for lunar surface technology development. And we'll talk about it as we get into the objectives in a little bit, but we're here also to try to create a sustainable presence in a lunar economy as we go through that. And you know, you can say, well, what does that mean? And for us, a big part of that, and of course, this time I think it's excavation and construction that's the emphasis of this particular conference. We do this twice a year, and then you know, at 2 different host sites, and then throughout the year, this focus groups and stuff has been talked. And so anyways, for us, if you kind of look at roughly the next decade of stuff, it's kind of outlined on this chart of the types of things we think we do on a lunar surface. We have, you know, we're interested in both water extraction through lunar ice, as well as oxygen extraction, and through, you know, through the regolith. There's a lot of oxygen in the regolith, and actually in the extraction of that, there's a lot of potential for getting metals and minerals as you go through it. Aluminum is present and stuff. So allowing creative minds to think about that kind of stuff and what can we do with it is a big part of what we do. And so, but right now, early stage, we're kind of at the ground demo of what we do for oxygen extraction, while the IM2 mission is our first implementation of a drill for ice water down to about 1 meter down. And that IM2 mission includes a hopper that can go around into craters and stuff, hop at about 1 mile at a time on the surface. as well as a demonstration of a 4G LTE network. Those last two things were things that we awarded through our tipping point solicitation, and we'll talk about that a little bit more. But it's one of our great ways to fund things as we go through here. And then we've got, as we get into the mid decades, we see, and then the Prime just feeds the Viper mission as we go through it, which is a large rover science mission, directorate mission, the same drill, same design, different part number, but the same drill that's being used and mass spec that's being used on the IM-2 mission will be used on Viper as well. And then we have these two kind of key, the commercial lunar payload services, the CLPS missions is critical, absolutely. We wouldn't have a lunar initiative without CLPS. We wouldn't be able to be talking about creating a space economy without CLPS. And so it's just an essential part of what we're doing here. And then there's a little bit of nomenclature, but CT1 and CT2 are two planned large integrated demos of technologies into one mission. So there are missions basically to lead. So following that IM-2 mission, which kind of is a teaser of getting things going, is CT1 and CT2. And so the idea is on CT1, since we've done some water extraction demonstrations, including through Viper, that we'd have an ISRU 02 demo in this timeframe of a pilot excavator for ISRU, surface power demonstration. There's been a lot of talk about VSATs, and that's one of our programs. And I think a fairly creative way of trying to develop power on the lunar surface where the sun's right at the horizon pretty much the whole time. And then also a construction demo, and then feeding into a second CT mission, which would be an ISRU subscale demo of one type or another. We'll see as it goes, and a following construction demo. And then ultimately, what we really want to do is put a fission surface power system on the moon. We have contracts now for a few $1 million, or for about $5 million for 3 companies they're working on developing that, and with that a pilot system. So the idea is, if you get there, then we can start saying we've done enough demonstration that NASA, that we're hoping that it helps spur those investments and the space economy and industry taking over. And so we've demonstrated things that get there, but there'd still be more. NASA can't back away completely, but what we do want to, by the time we get to here, we're hoping to be one of several customers, not one of only customer. Next chart. And then just a few other things that are on this. I talked the Intuitive Machines flight just now. You can see images of those. Astrobotic, we had a terrain relative navigation system that we developed for Perseverance, Mars rover. And it enabled that mission it worked perfectly. It's as you might imagine, you kind of sense as you're landing where you're going, and then it avoids rocks and stuff and picks out a spot for it. And we wouldn't have felt safe of landing in the Jezero crater, which is, if we didn't have something like the TRN as we go through it, and it worked perfectly. And now we're in a region of very high value from a science standpoint and potential water. And I noticed Astrobotic just yesterday, I think, made an announcement on their TRN system. We have a couple of these companies or a few of these companies that are looking to use and adapt the terrain relative navigation for their own purposes, for their own landing systems and stuff as to go through it. And Astrobotic was one of them, and they're on the Peregrine 1 mission, one of the first missions that we'll have of the CLPS. And they announced yesterday that they've gone through and validated the system and it's ready to go. And then there's other things like electrodynamic dust shield. I think there's been lots of discussion here about the challenges that we have with dust. And the funny thing about lacking water and lacking atmosphere is you also lack erosion. And so the dust becomes very sharp and pointed as a result, and actually fairly dangerous. The Scalps, I think, was just delivered for that CLPS mission, or maybe it was an earlier version of it. And Cadre is going to be a fun mission. It's too with the CLPS one at the end, demonstrating autonomous behavior among multiple rover scouts on the surface. Next chart, please. So there was a lot talked about LSI yesterday. Rachel does an outstanding job. Man, we couldn't do this without the wonderful work that's done by Johns Hopkins APL. And we're really proud we started thinking about what should we do. We need to do something to engage the community. And I think it was back in 2019 that we went through options and stuff, and we brought brought Nikki on board, and gave high level guidelines of this is the sort of thing we want. And then out of that spawned the great relationship with APL and the consortium, the initiative and the consortium as we know it today. The kickoff for that first time for this meeting, we've now had 6 of these type full meetings, was February 28th, 2020, which is easy to remember considering what happened in March of 2020. And so it's a hard time to get started, but our goal was always to reach every state, every district, every territory of it. And right now, we have reached all 50 states with participation, District of Columbia, Guam, Puerto Rico, and 46 countries and stuff on a regular basis. It has really amazed me how strongly the community has kept together for this. Really appreciate it. And APL also during this time has led and participated in a number of workshops and conferences. It's really it's bringing out the community's engagement, and then you write you document that in reports to us. It's data that we have. It's data for the community as we go through it, and really some fantastic leveraging that's going on for the community. And so I really appreciate Rachel, everything you guys do. Nikki, for everything you've done to set this up, and everybody that's supporting it. And I really thank you for being here. Next chart. So I'll talk the objectives some. I think it was not quite a year ago. The agency, well, actually, one of the things that you do here is okay, but what's the plan? What's the plan for Artemis? It's not a bunch of individual flights. How is this? And so what we did was we sat down and tried to develop Moon to Mars objectives. And so the idea behind that was to be, what are the kinds of objectives that we are trying to achieve? Talk about some of those in the next chart, and get this into a product that everybody has a chance to comment to and as a living document as we go forward. And so what we did is we started with our group. We called it the Federated Board. And so all the major mission directors are there. There's 4 of us that are kind of especially involved with the Moon Mars. There's Exploration Systems Development, or ESD, which does the major Artemis aspects to it. There's Space Operations Mission Director, the ISS, SCAN, and that's multiple other things like that. They got more operations side of human space. And there's ourselves, Space Technology Mission Director, and then Science and stuff. So each of us had representatives, and there's some other representatives too, to develop those objectives. And then we reached out to the community, first from NASA Workforce back in May, Industry and Academia Workshop in June, International Space Agencies. They were particularly excited or interested in this activity because they can see themselves. They can go back to their ministerials and stuff and say, okay, this is where we fit in and stuff. So we've really gotten strong support from the international community. And it culminated in July in a workshop that we had in the United Kingdom. And then also we went back and our NASA centers and stuff as went through it. And then we consolidated all that input and then we released this at the end of September, the quote unquote final product, it will be a living document at the ISC in September. And with that, it came out from the 50 draft objectives we started with, we ended up with 63 and stuff. And they're spread around 4 major categories. There's science, operations, transportation and habitation, and infrastructure. We led the infrastructure category, Space Tech did. But it doesn't mean that we do everything that's in there. It's a coordinated thing, and there's things that we do that are in the habitation and transportation, for example. And there's plenty of things that go there. So next chart. So then, in parallel to that, and actually a little before it, we were trying to put together our. Oh wait, I'm sorry, I forgot about this. Okay, we got I'm sorry, it's straining you, I know, to be able to read the words. It's straining me to read the words. I'm right here, but so I wanted to just talk a little bit about the infrastructure objectives, since that's the ones that we had, and just to give you a perspective, I guess, of the types of things there. And the idea is we get these objectives, they're high level statements, but then we fill out what are the gaps that we have to fill. What's the state of the art? And where are we going from here? And what's our priority as we go through it? So the idea, though, is in a lunar infrastructure goal is to create an interoperable global lunar utilization infrastructure where U.S. industry and international partners can maintain continuous robotic and human presence on the lunar surface for a robust lunar economy without NASA as the sole user while accomplishing science objectives and testing for Mars. And so, the thing that people have been asking as Artemis was growing is that it's an or question. Are you going to the moon to go to Mars, or are you going to the moon to develop a sustainable economy? And we say that's not the right question. The answer is yes. We're doing both, and we want to enable that community, and on the way, then that will help enable us to get to Mars. So just example of a couple of these I'll pick, not at random, but I'll pick. The Lunar Initiative 1, there's 13 total objectives in this category, 9 of which are lunar, 4 of which are Mars. One of the examples of a lunar one is to develop an incremental lunar power generation and distribution system that's evolvable to support continuous robotic human operation and is capable of scaling to global power utilization and industrial power levels. So we know we're starting out with relatively small power levels for something that would be an industrial scale, but you start somewhere and then you grow as we go through that. Another one, and I promise it'll just be the 2. Let's see, where to go. Demonstrate advanced manufacturing and autonomous construction capabilities in support of continuous lunar presence and a robust lunar economy. So I'll just say a couple things. First of all, we heavily emphasize that we're trying to support a robust economy on the lunar surface. The other thing is one of those started with the word develop, one of those started with the word demonstrate. The difference is, and that was carefully chosen, the develop ones are things that we want to actually put that capability on the moon for use. The demonstrate are things that we want to at least get to the point where we're demonstrating the technology for future implementation of a follow-up system. Next chart. And then in parallel and a little ahead of it, actually, for our mission director, we were trying to do something very similar. We wanted to have something out there that would be objectives based of what our strategy is. One of the things I love the science mission director ability to have the decadal surveys and stuff. Because the nice thing about that, when you deal with a lot of stakeholders that have their own opinions, what you should do is when you have something that you have an august group like the national academies, people don't question their priorities and stuff. So we can't, I love that, but it's actually turns out to be fairly expensive to do that, at least for a smaller mission director. So, but what we want, that's why we created these objectives. We said, okay, what's ours, and get it out in the community. Very similar to what we're doing with the Moon to Mars objectives. And so I know I'm kind of going over, so I probably have to speed up, but the fourth, we developed 4 thrusts. We call them euphemistically go, land, live, explore. With those, we identified 17 outcomes, 18 capabilities that we need to satisfy those outcomes. And then we had our principal technologists and system capabilities develop those outcomes into envision futures. And with that, what's the gaps that we need? What's we believe the state of the art is and stuff. And then we went through that, a similar process to get comments from the community. I guess that's on the next chart, so I'll go on from there. But the overarching thing is to lead. And these objectives to ensure American global leadership in space technology. And then we have objectives around that. So, so for us, this is in parallel. This system, we were working in parallel, but the things, especially in the live category, map directly to the Moon to Mars. But there's also the things that are in Moon to Mars that aren't us, so they're not on this list. And there's also things that we do that are beyond Moon to Mars, and so they are in here. So that's how that kind of works. Next chart. And so we did go through a process of getting information, and then at the SEN conference last week, as we introduced the SPAC, and we had workshops there among all those capabilities, and really extremely well attended. We really weren't sure how it was going to be, but people kind of came in, stayed all afternoon talking the objectives and talking those packages and stuff. Next chart. I won't go over this in detail, especially given I've used up most of my time, but I just wanted to say, we don't make awards through the initiative, but we do make a lot of awards through it. And the strength of our organization, I like to say, is our breadth of what we do. And so so this is just a snapshot of over the last 5 months or so, what kind of selections we've made. It's about $200 million worth of stuff to the communities as we go through it. Next chart. And then one of our most popular programs is what we call the ACO and Tipping Point. These are invitations. Basically, it's you got to have stake in the game. It's a partnership. For a large business, it's at least 25% of the value. For a small business, it's at least 10% of the value. And in there, we actually had a pretty open call. And what we do is we have it at 2 phases. The first phase being preliminary proposals. So you don't have to, and you don't have to have, you just have to have ROM costs. You have to have good concept and stuff like that. You don't have to have the full proposal. And then we narrow that down and invite a certain number back. And when we pick that number, 2 minutes. You're being generous. When we pick that number, when we pick that amount that we invite forward, I like to try to tell people is I want to have people feel like they have a pretty good chance of getting picked if you're in one of those down selects. And by that I mean ideally it would be 1 in 3 proposals that we would fund after we did, but it might be in this case 1 in 5. One of the problems we have is our budget, of course, has been flat for 2 years in a row, and we're not going to make these awards until we see what our appropriations are. If we're flat for 2 years in a row, we just won't be able to award, almost certainly. So, anyways, but the final proposals are due in 3 weeks, and then we'll go through there. And we tried to, at least from the proposer side, not to have them work over the holidays for this. And in our future, this is actually a little bit dated. The ACOs, I haven't really gotten into them, but it's a non-reimbursable thing with SpaceX. Our intent is to do that basically in an open call as we go forward. And for tipping points, it'll be every other year. Next chart. And I think I'll just pass since I want to go to like the last chart or two. But we do a lot in cryogenics, in solar electric propulsion. We've got a couple of really great missions coming up. The Lunar flashlight is going to do a near rectilinear type orbit and search for water using near infrared lasers. At that highly elliptical orbit, it'll be within 9 miles of the surface, and then they go out to 40,000 miles or something like that. Next chart. I want to put a shout out to the New Shepard, to the lunar gravity flight. We're really excited about the potential with that vehicle on suborbital space to get a couple minutes time at 16G or whatever you dial it in as you go through it. And we filled that up, filled up our allocation for that pretty quickly, and there's 12 there. And I just want to say, you can kind of read the words: regolith properties, crew safety, dust mitigation, but also ocean worlds have a very similar gravity. And so we found a lot of interest in that community. Next chart. And then 2 things coming up that we're both excited about, like within the next week. First of all is the lofted demonstration. We dedicated it to a ULA manager who died suddenly, unexpectedly, to Bernard Cutter, because he was such an instrumental part of this mission. And the idea behind this is use a inflatable design to create a huge drag area. This would be 20 feet in diameter, about 6 meters in diameter when it expands and stuff. And with that, land on very difficult and challenging places to land with that have gravity. It's on the JPSS-2 mission, and we're anxious to see it on liftoff on the 10th, November 10th. And then also Capstone, the little spacecraft that could, is about to enter the near rectilinear halo orbit on the 13th. And it's doing great right now. So next chart, and I'll end. It really is a pleasure to be here. We are committed to help inspire and to reach parts of the community that we don't reach before. That's a critical part of what we do. And one of the ways we try to do that is if you're going to inspire, do it in the middle schools and stuff. That's especially, and that's why we created the first one. It's a graphic novel that's done it tremendously well. I think it's a great story. We have another one to work, but we're not professionals at this, and we got to get the story right. So with that, I'll declare success. Thank you.